All right, Panthers, my growth mindset, math maniac, math side, penny, mindset, growth mindset, math maniac, Panthers, growl. All right, so here's the thing. We're going to finish up lesson 4.09, 4.08, 4.09, coordinate plane and distance on a coordinate plane. Okay, so let's get started. What is the coordinate of this point? The x and the y. I use the x for red, y for blue. So if I go from this point until I get to the red line, I end up with a 4. So that's going to be my x value is 4. Go my y value. Boom, boom, boom to the y-axis. I get a 3. That looks like a -3. That's just some kind of weird typo thing. I don't know what that is. Ignore that. It's a 3. Okay, so this is a 3. So 4, 3. See, straight down, straight across, 4, 3. Again, ignore that. It looks like a negative sign there. It's not supposed to be. Okay, next. How about this one? What's the coordinate for this point? Try it out. Oh, how'd you do? Start with the red, go to the red one. That's a -4. So my x value is -4. Oh, here, let's do it this way, -4. And what's the y value? Y goes straight across to the blue, -2. So here we go. How about this one? We already did this one. Yeah, there it is. Redo. How about this one? Okay, I think we're getting the idea here. Let's just go. Which dot has the coordinate 2, 3? Is it A or B? I like to start with the red. Let's take A down here. Oh, that's a 2. And that's a 3. I don't have to go any further. Again, my funny 3. You're so funny, 3. So it can't be this one. This one, what's this one then? This one would be 3, and then it would be 2. Be careful with that. Okay, what do all of these numbers have in common? Well, one of the things that somebody said, they're all whole numbers. Good, good. And what else do they all have in common? They're all less than 6. Yeah, okay. Okay, I'm kind of going for something else here. What else do they have in common? They're all positive. Okay, now that's what I'm talking about. All of these are positive numbers. And they're all in quadrant. Somebody says quadrant 1. So we'll just put quadrant 1. Everything's in quadrant 1. So that's going to be the case for every pair that you put in quadrant 1 are always going to be positive. There's some happy numbers in this section of the world here. This is a nice place to live, right here. Happy Land Quadrant 1, which in Roman numerals is written with the letter I. I am happy. I am so happy. Now, what about negative Nellies? Where would all the negative ones live? Nothing but negativity. Well, we're going to find out in a few moments. But before we get to negative land, which everyone has to be there sometimes, that's just life. Joy and pain is like sunshine and rain. Okay, but rain is a good thing sometimes where I'm from, let me tell you. It makes the barley grow and makes the corn grow and all kinds of things. Okay, so next. What about this one? What do you notice about all the x values? Let's talk about the x's here first. Negative, negative. Oh, look, they're all negative. And they're all in quadrant. Bam, 2, which is written with like this. But the really nice thing about these guys is that they have this y value, so they're not always negative. They may start out negative, but they end positive, so that's really nice. All's well that ends well. So they're kind of like, happy, sad. Now here's the negative Nellies. Look at this negativity down in here. Negative, negative, nothing but negativity. Such sad. But we all come down there sometimes in this negative land, and we get kind of have our moments of being mean sometimes. Try not to be there very much if you can help it. But sometimes you have grief and sorrow, so we all have to be there sometimes. I like Marshmallow. He's a little sad Marshmallow character. I didn't mean that, but there it is. Okay, but you can also be in happy land and negative land sometimes at the same time. You say, how can you do that? Let me show you. See, Marshmallow here is all in negative land. What if we had Marshmallow like this? He's kind of like in all the lands now. So you can kind of have your body, your face, your head, whatever, in all different places at once. It's possible. Okay, let's move on. What do all the y values have here? All the y's are also negative. So this is a negative, negative. Okay, here, what do we have here? Positive, negative, positive, negative, positive, negative. So let's review here. This is the big takeaway. So all the purples are positive, P, purple for positive, and the greens are neg. I figure, well, the G sounds close as I can get right now. G, negative. Okay, I like green, by the way. It's one of my favorite colors, so don't think that I'm being biased, all right? Which I probably am. Okay, Q land over here again, as we have said, all of this is positive, positive, no matter what you put in. Okay, here, Q2 land. That's Q1, Q1, what's Q1 again? Q1, oh yeah, quartile, no, quadrant. Quadrant 2 is first negative, then positive. Quadrant 3 is negative, negative, nothing but negative. Sorry, 3. Quadrant 4 is positive, negative, but positive comes first, negative second, where if you look up here, it's the opposite. Negative, oh, did you notice, did you see that? Diagonals are opposites. Because if you go diagonal from the positives, you get negative, negative. That's really cool. Okay. Which quadrant will we find the coordinate 3, 4? Now I'll do purple, purple. Purple rain, purple rain. Positive, positive. This is quadrant 1. Bam. How about negative, negative? We'll go back to green for negative. Remember? Just the opposite of that down here. That's quadrant 1, 2, 3. And Roman numerals is 3 eyes. Okay, how about this one? Positive, negative. Ooh. Purple, which one has the positive coming first? I know it's one of these two here. It's either this one or this one. I can't remember. Which one has the positive first? Oh, if I remember how to look for coordinates, I go x, y. So here's x. And all the x's are here are going to be this way, which are positive. The y's are negative because the y's go down. So my y's are negative. So this one has the negative second. So which one has my negatives? Yeah, negative second. There it is. Negatives are second, and the positives are first. See, x's positives come first. So that's got to be quadrant 1, 2, 3, 4. Quadrant 4. Dun, dun, dun. Oops. I thought that was a highlighter there for a second. We'll use this one. There we go. Next, I think you guys get the idea. All right, let's just go. This one's a fun one. Negative, negative. That's easy. Boom. Positive, positive. Boom. Okay, determine the distance. Here's the big one. Big distance between 2 points. Okay, first of all, can I determine the distance between 2 points? Here's a point. Here's a point. The distance would be the red in between these 2 points. What is that length? And it says using ordered pairs with the same first coordinate. See how this is the same, 5 and 5? Or they could be the same this way. Of course, this time it says 4 and 4. So back here, the x's are the same. Here, the y's are the same. And they could be in all 4 quadrants. This distance from here to here is in quadrant 1. This distance quadrant 4. Which quadrant is this? Oh, the negative land 3. But they could also go across quadrants. Like they can go from this, what is this one, 2? From 2 to 3 and from 1 to 4. They can go all over the place. So let's begin with this one. Find the distance of these 2 points. First thing to notice is when the x-coordinates are the same, the points fall on a vertical line, vertical up and down. And what are we talking about? X-coordinates. I like to use red, -5, -5. We know that's a straight line up and down. So how do you find the distance between these two? Take the y minus the y. 7 minus 2 is 5. Is there 5? 1, 2, 3, 4, 5. There it is. So just take the y2, which is the bigger y, in this case 7. The y1, we'll call it 2. 7 minus 2 is 5. Let's call these the ones that we don't use. Okay, first of all, let's identify the ones that are the same. Those ones we don't use. So I'm just gonna like cross them off. We're not using those. Now the 2 that we do use, the 7 and the 2, we're gonna call these DCs, distance coordinates, because those are the ones we use in our problem, the 7 and the 2. We're not using this, whatever this number was that I can't remember because I covered it up. Oh, those -5s. Bang, just forget about it. Okay, so what are the DCs here? Well, the 4 and the 4 are the same, so those are not the DCs. The DCs are 8 and 2. We simply take the bigger one, 8, minus the smaller one and get 6 units. What does that look like on a graph? Looks like this. 4s are the same. We're not using those. The distance coordinates are 8 and 2. 8 minus 2. Let's see, what does that give us? 1, 2, 3, 4, 5, 6. Isn't that what we said? 6 units? Yeah, 6 units. So, well, in summary, when we have these coordinates of y's, we're not, again, let's just do this. This is confusing me. Let's just block these ones off. The DC's. When the DC's are both positive, subtract the bigger one minus the smaller one. The DC's are both positive. This case, 8 minus 2, we subtract. When the DC's are both positive, subtract. Okay, you find the distance between these 2 points. Check back with me. Oh, okay, how'd you do? This is a video, you could have paused it. All right, so let's see, which ones are the ones that are the same? This is the same as this. So I'm not using those. So the DC's are 2 and 4. 4 minus 2 equals 2. 2 units. Is that what you got? I knew you would. I knew you'd get that. If you were to do it on a number line, I'm not going to spend too much time on this, but see, negative 1 and 2, 1, 2. There's 1 point. And then negative 1 and 4. Negative 1 and negative 1 and 4. 1, 2, 3, 4. So, there's our 2 points. I'm going to erase the little mistakes I made there. And so what's the distance between these 2 points? You can just easily see it's 2, or you would do 4 minus 2. 4 minus 2. 2. Okay, we'll try another one, but let's skip this one. What's the DC of both, or when they're both negative? So now we're doing a different kind of problem. See, because before we did it when they were both positive. See, like this one, for example, which we skipped. So this is the same. So these are not the DCs. These are not the distance coordinates. It's 6 and 1. All you do is do 6 minus 1 is 5. But this one here, let's see what we got. So the negative 3's are the same. We're not using those. We're just using the negative 5 and the negative 2. Now what do we do? Negative 5, negative 2. Do we subtract them? Do we add them? I'm a little confused here. All right, let's just erase this for a second here and see what it looks like on a graph. Okay, so again, the ones that are the same were the negative 3. We're still not going to use those. Those are not the coordinate points, the CDs, DCs, the distance coordinates. Okay, but it's negative 5. But what is the distance? So let's count it up. Ready? 1, 2, 3. So what do we do with negative 5 and negative 2 to get 3? Negative 5 and negative 2 to end up with 3 somehow. Okay, well, I guess we would just do 5 minus 2. And so what are we really doing? Since they're distances, we're saying that this is the absolute value of 5. And we know absolute values, ready? Absolute value is a distance, and distances are always positive. Absolute value is a distance, and distances are always positive. Absolute value is a distance, and distances are always, like in the wall, positive. So we're going to make that positive. And we're going to do the same thing here. And we're going to still subtract. So we take the absolute value of one of them is 5. Subtract, take the absolute value of the negative 2, that's a 2, and we get 3. There's our 1, 2, a 3. Okay, find if between these 2 points, 5 minus 2 is 3, so that's what we said. Take the absolute value, the x2 minus the x1. Again, let's just cross off the ones we're not using, just so we don't get confused. These are these ones we're not using. These are not the DCs. Take the DC here, take the DC here, like negative 5 becomes a 2, negative 2 becomes a 2, subtract 3 units. You try this one. Okay, how'd you do? Let's find out. So which ones are the same? The 4 and the 4 are the same. Those are not the DCs. But negative 2 and negative 4 are the DCs. Absolute value these things, and then subtract, right? Absolute value negative 2, 2. Absolute value negative 4, 4. Uh-oh, I can't do 2 minus 4. So that's an easy fix. Reverse the order. 4 minus 2. 2 units. See what that looks like on a graph? What are the ones that are the same? The 4 and the 4 are the same. We're not using those. All right? Because that's just this 4 right here. That's what that means. That's the up and down 4. all right? Or it's really the side to side. It tells you where everything is side to side. They're all on the same side to side. That makes it up and down. So we got -2, -4, and what is the distance here? Well, 1, 2, 2 units. So we just do 4 minus 2. Well, the absolute value of -4 minus the absolute value of -2. All right, so there it is. So what do we got here? If the DCs are both negative, take the absolute value of each of them and subtract. So we're still subtracting. Okay, and we could go on here with examples, but let's review totally what we've done so far. We said if DCs are both positive DCs, here, let's cross off the ones we're not using to make this more clear. We are not using these. We are not using these. Ah, there we go, just the green ones with the circle. The green ones, so they're both positive. 7 and 2 are positive, 2 and 8 are positive. All you do is subtract, right? But what if they're both negative? Take the absolute value of them and subtract. Now, just to keep things easier, there's a lot of writing on here. All this says is to make things easier, which maybe I'm not making things easier by writing all this stuff, to remember and to make it more mathematically correct, because we are talking about distances, and distances are always, even if they're positive distances, they still stay positive, right? They're always positive. The absolute value. It's going to be easier just to say, you know what, so far, no matter what we get, you're just going to, take the DCs are both positive, they're both negative. In other words, they're both the same. Take the absolute value and subtract. That's easier than trying to remember different things for these. So let's keep the same. All right, let's go. What if there's the last case? This is it. There's only one more possibility. Either they're both positive, the DCs, or they're both negative, or what's the last possible way? That's right. One could be positive and negative. One could be negative and positive. Either way, they could be mixed. Let's see what happens if they're mixed. This is where it's a little bit different. Find the distance between the points. Again, let's find out what the DCs are. Well, first of all, which ones are the same? This is the same as this. So these are not the DCs. So what are we going to do? Something with a -3 and something with a 2 to get something. Let's see what that something is. Let's look at the graph and see what the graph says. Okay, so again, these two are the same. Nope. Okay, so we had -3 and 2. Let's say, what is the answer supposed to be? 1, 2, 3. Ooh, I just thought of something, and then 1, 2. Aha, so this 2 here is this right here. This 2 represents these 2 units. This 3, I'll find the purple, represents these 3 units with a -3. You thinking what I'm thinking? You thinking distances, right? Distances are here. Absolute values are distances, and distances are always positive. All we got to do is take the absolute value of these things, but this time we don't subtract. What do we do? Remember what we got? It's supposed to be 5. What do you do with 3 and 2 to get 5? Add them up. So this here is -3, right? Absolute value. Plus whatever this is, this green up here. I don't really call it, we'll keep going this way, which is a 2. Absolute value of 2. Let's just take absolute value just to keep things easier, and then add. Take the absolute value and add. What's the absolute value? Okay, let's do this. This is here. This is the 3 up here, and this 2 is here. So this is going to be 3 plus 2 equals 5 units. Find the distance. 3 plus 2 is 5. Take the absolute value of both of them. Add. Same thing here. You try this one and see what happens. All right, how'd you do? Let's see. 2 and 2 is the same. These are not the DCs. You are not the DC. I won't go into what I was thinking. Morabovich thing. We'll stay away from that. But these guys are the DCs, the 2 and -2. What do we say we're going to do? Take the absolute value of each of them and add them together. So what's the absolute value of 2? Is 2. It's already positive. Add absolute value of -2 is 2. Make them positive. They're positive. Distances are positive. And we get 4. Let's see if that works out on the graph. Graph, please. -2's are the same. That means we're not using those. Those are not the DCs. There it is. See, what is it's just, wait, let's count it up. 1, 2 is on that side. 1, 2 is on that side. That's 4. See, it's really, if you think about it, this -2 is just the distance from 0, because this is a 0. This is the ground. How far are you from the ground level? You're 2 units away. That's the absolute value of -2 equals 2. That's 2 units. This is 2 units. 2 units up, right? Absolute value still is 2. That's the distance. Okay, 2 plus 2 is 4. Okay, we're not going to find these. Time is running out. Oh my gosh, it looks like so much, but it's really not. Watch, I'll show you. Ready? So the first thing is either they're the same. The signs are both positive or the signs are both negative. Signs are both positive or the signs are both negative. Either way, you take the absolute value and subtract. That's it. Now, what if they're one of each? What if it's negative positive or positive negative? This time, you take the absolute value and add. It's that easy. Absolute value and subtract, absolute value and subtract, or absolute value and add. Doom, doom, doom. Yes. Attack the day. Sometimes I have to tell yourself I'm a shark and attack the day. Oh, wow, that's cute. I didn't see how cute this really was here. There's a shark. You see that? Baby cat, shark, 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 shark. Baby cat, shark, 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 shark. Catty shark, 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 catty shark. Okay, that's it. We're done. Bye. Bye. How do I stop this thing? Was I even recording?